Okay, in this presentation we're going to look at the rules for integration. Now we're just going to look at two rules in particular. They're easy enough rules. The first one is called the sum rule, and essentially we have two expressions, u and v, and they're both functions of x. And when we get the sum of these two expressions, u plus v, and we're finding the integral of those. Essentially what we could do is break it up into two parts. We find the integral of u, the first part of the sum, integrate that, and then get the integral of the second part of the sum, v, integrate that, and then just add them together. Just so, the second one is so that's called the sum rule. The second rule is called the factor rule, and it is just when we have this factor term or coefficient. So k is some value, like 1, 2, 3, 4, 5 or something like that, or pi, or essentially it's not a function of x. So if u is a function of x and k is not a function of x, and you have this product k times u dx, you can actually take this term value k out of the expression and integrate it, just like multiply it by the integral of u dx. Now, importantly, it is not an expression in terms of x. This rule only applies in that case. So it is usually for coefficients. For example, 2, 3, 4, 5, and 6, and so on. Let's just look at some quick examples here. So you should be familiar with the how to do sort of straightforward integration by now. So integral of x squared plus x cubed dx. We can write that as the integral of x squared dx plus the integral of x cubed dx. The undetermined coefficient, you can just put that in at the end. So you can just sort of evaluate them without the undetermined coefficient. X to the power of 2. Well, 2 plus 1 is 3. So we have x to the power of 3 divided by 3. X to the power of 3, well, 3 plus 1 is 4. So plus x to the power of 4 over 4. And now we can put our undetermined coefficient in there at the end, plus c. Okay, so that one's simple enough. That's using the factor rule. The next term here is, let's just go 3 times cos of x, let's say, and get the integral of that. And so let's just look at that. 3 times cos of x. So that is equal to 3 by the integral of cos of x dx plus c. And that is 3 times, hang on, I'll just check this now, is 3 times sine x. Actually, I just wanted to check that I didn't drop the sign, plus c. So simple as that. This is where you could go wrong. Let's just say, for argument's sake, it was the integral of 3x cos x dx. That is not equal to 3x times cos of x, the integral of cos x dx. That's wrong. Okay? The reason is this expression here is a function of x, which is what we're integrating with respect to. Okay? So that's wrong. Okay? So there's a different technique you'd use there. It's called integration by parts. You'll probably be seeing it very soon. But in that case, that's what to not do. Okay? Alright. Let's move on from that. Let's just do a sort of little quick example of using the two rules together. And actually, I'll just base it on what I've just done there. The integral of 3x plus cos of x dx. We can write that as the integral of 3x dx plus the integral of cos x with respect to x dx. And so we can actually write that as 3 times the integral of x dx plus the integral of cos x dx. And that's equal to 3x squared over 2 plus cos x. Or sine x. Integral is sine x. And put it in your undetermined coefficient c. Alright. So I'm going to do a sort of, that's so far so good. I'm actually going to do a sort of rather complicated example now, just to sort of finish up this example. I'll just get it from my notes here. It is the following. Okay, so go to a new page here. We're going to integrate this. I for integral is equal to e to the power of x by the cosh of x dx. And if you're familiar, you might be looking back at this video thinking, is this an integration by parts question? You're right, you could do it that way. What I'm going to do here is we are going to remind ourselves that cosh of x is equal to e to the power of x plus e to the power of minus x all over 2. And you're thinking, you can simplify this, can't you? So that's right. I is equal to the integral of x times integral of x, the integral of e to the power of x times e to the power of x plus e to the power of minus x all over 2 dx. What I'm going to do is take this 2 out of the equation. I'm going to use the factor rule, so I'm going to put it out here. Or it's a half essentially, so we're just bringing it out. I'm going to bring it out using the factor rule to bring it out in front of the integral. That's the integral sign, that squiggle here. So e to the power of x times e to the power of x, that is equal to, sorry, I just have to keep control of my font size for my pen. That's equal to 1/2 of e to the power of x times e to the power of x. That's e to the power of 2x. And e to the power of x by e to the power of minus x, that's 1. Okay, so if you multiply the whole thing out, you get that. Okay. Now, that's how we could evaluate that. Let's go to a new page again. Let's go to a new page. Let's go here. Sorry, just to add a new page to this software. So 1/2 e to the 2x dx plus 1/2 the integral of 1 dx. And the integral of e to the 2x is special, using a special formula that actually I should just discuss now. This is just a sort of standard integral, as we call it. The integral of e to the power of a times x, where that's a is coefficient, like 2 for example, that is equal to e to the power of ax all over a. Actually, I should have made that a bit clearer, but there. So you divide by a as well. So this term here, 1/2 integral of e to the 2x dx plus 1/2 integral of 1 dx. This is equal to integral of the e2x over 2, and again that's pre-multiply that by 1/2, plus 1/2 of x, and also we have our undetermined coefficient there, c. So e to the 2x over 4 plus x over 2 plus c. So that's the answer there to that part. So that's just a sort of quick introduction to some rules of integration, some important rules of integration. And we did a rather tricky example there. That wasn't easy. Alright. Well, it was easy, but it wasn't so obviously easy. Okay.